As we are going to review going from standard form of a quadratic that looks like this into vertex form, which looks like that. Let's review some factoring of perfect square trinomials. If we wanted to factor something that looks like x squared plus 8x plus 16, we would find two numbers that add to get 8 but multiply to get 16. And you would write it like x plus 4, x plus 4. But instead of writing another x plus 4, it's easier just to write it as x plus 4 quantity squared. Number 2 over here with the m's, again, what adds to get negative 18 but multiplies to get 81. Those two numbers are negative 9 and negative 9. So you write it as m minus 9. But instead of writing another m minus 9, you'd write that one as squared. Try the other two on your own to practice factoring a perfect square trinomial, because you're going to need to know how to do this in order to convert from, again, standard form to vertex form. In order to do that, we're going to use the method known as completing the square. You may have seen this in Algebra 1. It may have been difficult for you. So I'm going to show you a diagram in class on the visual way of completing the square, and I'm also going to show you a little shortcut on how to complete the square, little formula. Read all 5 of these steps about the grouping, about if a is not equal to 1, you factor, you complete the square, you subtract and factor. These might be a little confusing for you, so I'm going to go through these and reference them as we complete the square for number 1. The first step is to take the ax squared and the bx, put it on one side, and I am going to move this c term to the other side of the equal sign. And in order to move it to the other side, I'm going to do the opposite, so minus 4. And now that's why it becomes a negative 4 on the other side. So again, that's step 1, grouping the ax squared. Step 2, I guess since is a equal to 1 here, so you don't have to worry about step 2 here, but we're going to skip over to step 3 and we're going to complete the square. What you do is you take half of the b term, so half of 4, and then you're going to square it. Half of 4 and then square it. Half of 4 is 2, and then squaring it makes 4. You take that number and you add it to the end of each expression. I'm going to add it at the end here, and then I'm going to add it at the end of the other side of the equation. So we're basically still balancing it out. We're not changing anything since we're adding 4 to both sides of the equation. What happens on the left side is that this now becomes a perfect square trinomial. And then when we complete the square, it's always going to be like this. It's always going to turn into a perfect square trinomial. And you're going to factor this to x plus 2, but I'm going to write it as x plus 2 squared, just like we did up top. And that's going to equal 0. The next step is to now write y equals that, and we wrote it in vertex form. We're done. Let's go on to number 2. Again, you take the ax squared and the bx on one side, and on the other side you move the c over, so you do the opposite of that one. Then you're going to take half of b and then square it, so half of negative 8 is negative 4. Squaring it makes 16. I'm going to put in a different color so you can see what I'm doing there. And then not only do you add 16 to one side, you're also going to add it to the other side. On the left side, what it makes a perfect square trinomial. And what that is x minus 4 squared. On the right side, this simplifies to be negative 2. Now, this is a little different than the other one because the other one had a 0. What we have to do now is move this c value back over, So our final answer is going to be y equals negative x minus 4 squared plus 2, moving that negative 2 over. So this is standard to vertex. Let's do a couple more. What if there is an a value that's not 1 here? Let's look at that. So we're going to take the ax squared and the bx on one side, and I'm going to move the c to the other side. Now what you have to do is you have to take out the a value by factoring. So you're left with this, x squared minus 6x. Keep the negative 13 on the other side. Now we can take half of b and add it and square it and add it to both sides. So half of negative 6 is negative 3. Squaring it makes 9. And you're going to add that to both sides. Rewriting everything we got back down, we have 2 parentheses. Here is our perfect square trinomial. So it's going to be x minus 3 squared, because that's what x squared minus 6x plus 9 is factored, equals what's on the right side is the negative 4. And we write our final answer as y equals 2 parentheses x minus 3 squared. But you have to move the c value back over, so it's going to be plus 4. Again, that's what you do. You have to divide out that GCF 2 first. But again, you only divide it out with the a and the b term. The c again is moved to the other side. Back and look at one that is negative in front. So number 9, you're going to do the same thing. You're going to take the ax squared and bx here, and then move on the other side the c value. You're going to factor out the number in front. So here we're just going to factor out a negative 2. And you're left with x squared, but a minus 10x equals the 46. Now we're going to complete the square. So we're going to take half of b and then square it. Half of negative 10 is negative 5, and then squaring it makes a positive 25. And don't forget, a lot of people forget to, again, add it to the other side. Now what we made here is a perfect square. Trinomial, so it's going to be x minus 5 squared is going to equal 46 plus 25, which is, I believe, 71. And then you're going to move the c value over, so your final answer is y equals negative 2, parentheses x minus 5 squared minus 71. Notice how, and it's not a coincidence, this is always going to happen, your a value in standard form, so in this case it's negative 2, is going to be the same a value that's in vertex form. So that's always a nice little way to check to see if your equations are accurate. We'll go over how to convert vertex back to standard. It's actually a lot easier. You're just doing the double distribution foiling method. Let me know what questions you have on completing the square for tomorrow, and have a great night.